Hello, eighth grade. We're talking about a single topic this week, a process called completing the square. It's a way to solve quadratic equations that may not be factorable. And we're going to take our time to get there. I'm just going to give you a relatively simple assignment today. And then the assignment the assignment Thursday is actually Thursday and Friday. It's one assignment that will cover the 2 days. Okay, because I don't necessarily want you to just rush through it. I'd really rather you just sort of focus on the process. Probably need to write things out and take your time doing it. Okay, I'm recording this in advance, but hopefully I was able to spend a little bit of time during our live meeting to discuss this. Actually, our live meeting would be tomorrow, since this is going to be Monday's recording. So hopefully tomorrow I'll be able to spend a little bit of time discussing the process, and that and the video that is there, I'm hoping will be enough. So completing the square is really basically taking an expression, taking part of an expression, say the first two terms of a trinomial, and then making that into a perfect square trinomial, like a plus b squared. One of those special cases we talked about before break, we talked about last week, and things like that. So what I have here is a website. You don't actually have to use this, but I'm going to show you visually how it works. And when it works, I'm going to pull out what's called algebra tiles. And the first expression we're going to complete the square with is h squared plus 12h. So I'm going to grab a pen. And we have to figure out what are we going to add or subtract to this to complete the square. Okay, and actually I think there's a plus sign here. And that's all today's assignment is. So I'm going to model this with what are called algebra tiles. And I'm going to take out, I don't have an x squared. I'm going to use an x squared instead of h squared. Okay, and 12h. So it's 1, 2, 3, 4. I should have chose a different number to start with. So I'm going to pause this video and I'm going to get till I have 12h. Okay, that was fast. And I've set this up in this way because of a very particular reason, okay? But there's my h squared or x squared. And I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's. So those algebra tiles represent the first part of that expression, h squared or x squared plus 12h. And really what I want to do is just sort of complete, if you picture this, the square. I want to think about what do I add in this big empty space here to complete a square. Okay, if you think about polynomials or trinomials we're dealing with, that's usually a constant. Well, that's where these one tiles come from, or what's called a unit tile. Unit tile, notice, fits very nicely right there. And I can start grabbing unit tiles in. And you might notice that the space it's going to fit is actually a square. That there's going to be 6 unit tiles along this side, 6 unit tiles here, and there'd be a total of 36. And if I added all 36 unit tiles in, I would have a square. So what makes this a perfect square trinomial is the number 36. Notice, because if I factor that, it becomes h plus 6 squared. H times h is h squared. H times 6 is 6h. Double that is 12h. And 6 times 6 is 36. Okay? So the number I have to add to that expression to complete the square is 36. And I'd like you to just think about 36 and 12 for a moment and sort of the relationship between the two, because this is going to be the relatively simple way of doing that in a moment. So I'm going to clear the screen. Okay. And I'm going to set up another one. So I'm going to pause it and get another one set up, and then I will be right back. Wow, that was fast. So it's all set up. The expression is x squared minus 10x plus what? What am I going to add to this to complete the square? And so I have my x squared here, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 negative x's, which is minus 10x. And again, picture what I have to fill in with my unit tiles to in effect complete the square, or not to in effect, but to complete the square. And notice what I'm doing is I'm going to be 5 by 5 each row. 5 that way, 5 that way, which means I'm going to have to add a total of 25 to that to complete the square. So to complete the square, I add 25. So when it's 12x, we added 36. When it's negative 10x, we added 25. Maybe you're already seeing some sort of relationship here. I'm going to do one more, discuss the relationship, and then one more problem after that. And then that's probably going to be it, and I'll show you IXL real quick. Okay, so let me set up one more problem. Okay, here's our third example. Again, completing the square, what do I add to that expression? X squared plus 6x, x squared plus 6x. What do I add? I can do these all because I kept the numbers small this time. 1, 2, 3, and one more makes 9. And notice we've completed the square. It's actually the first one we've actually completed because I kept the number relatively small and I didn't want to drag over 36 or 25 ones. But we completed the square here by adding 9 to both sides. Now, let's talk about how we can get that number without actually making an example here with algebra tiles. Well, look at the relationship. Again, if the standard form for a polynomial, leading coefficient 1, or quadratic polynomial, is x squared plus bx plus c. Look at what's happening here between b and c when we complete the square. C ends up being the square of half of b. In the first one, b was 12x. Half of 12 is 6. Square that is 36. In the second one, b is negative 10. Half of that is 5, negative 5. Squared is 25. And in this one, b is 6. Half of that is 3. And the square of 3 is 9. And that's really what it is. What you're going to add to complete the square if it's in this form. And we're going to talk about that tomorrow. We're going to talk about that in the video. If it's in this form, you add half of b squared, or the square of half b. Okay, so one more to sort of look at, and then I'm going to get to the IXL assignments. I'm going to clear the tiles. Let me erase all the writing. What about if I have something like, x squared plus 5x plus what? What do I add to that to complete the square? Well, it's the same thing. Half of b squared. There's b. B is 5. Half of b is 2.5. Oh, 2.5 squared is 6.25. So to complete the square, I would add 6.25 to both sides. Okay, so let's take a look at IXL. And what you're going to be doing, I'm going to jump down to the very beginning. There's only 2. Okay, I'm going to have to edit this together because I realized when I switched tabs, I forgot to do it. But to complete the square, you add half of b squared to both sides. Well, b is negative 12. Half of b is negative 6. Square that, you get 36. B is 18. Half of 18 is 9. Square it is 81. B is 24. Half of that is 12. 12 squared is 144. Okay, real quick, relatively simple. Even when you jump up a level, okay, jump up a level, oh, you get some odd numbers. Okay, well, half of 17 is 8.5. Square it, 72.25. That's it. That's today's lesson. I need to now go back and edit this a little bit because I goofed up a bit, but that's okay. I think you've got this. I will talk to you tomorrow. And then Thursday and Friday, you'll have a little bit more complicated assignments. So that's why I'm taking this real slow this week. And we'll see you then. Bye.